So welcome to this first session of the day. Of course, we already had a keynote from Kim Manis, so you got a great introduction to Microsoft Fabric as well as some invitations to websites and conferences. This session is about SQL. So the purpose of this session is to show you where you can use already established SQL skills, or if you plan to learn SQL, I will justify why you should learn SQL when facing Microsoft Fabric and when you want to work with data effectively on this platform. Also, for SQL developers, there will be some tips on what you should learn and what additional skills you should get in order to make your work with Fabric even more productive than just with SQL. My name is Pawel Potasinski. I'm a member of the Microsoft Fabric Customer Advisory Team with almost 20 years of professional experience working with data for all my career. I used to be Microsoft most valuable professional years ago, and I was a founder of what is right now called Data Community Poland. If somehow you are planning to go to SQL Day conference in Wrocław this year in May, then this is the thing I started in 2007, so years ago. And most of all, I love SQL. So that's why I decided to put this session on my as my submission. Thank you for accepting my submission, by the way. If you want to connect with me on LinkedIn, feel free to scan the QR code and just join my network. You can easily find me on LinkedIn, I believe. Now, this session is heavy, full of demos. I will try to limit the amount of slides to minimum. There will be just one meaningful slide for you. And I will share the deck after the presentation. There's a link to my GitHub I will provide, so no worries, you don't have to take screenshots. So first of all, I will start with why you should care about SQL, why SQL is still actual and it's a valid skill in Fabric, not just in Fabric, but in Fabric specifically. Then I will show you places where you will find SQL useful in Fabric and what you can actually do with that. And then there will be a summary full of links, resources, and call to actions. Also, please note that I will be using my virtual assistant called T-SQL Rex. I picked Dinosaur because dinosaurs and SQL have something in common, but they are both old and powerful. And T-SQL Rex will bring your attention to some things that you should note. For example, things that you may consider for learning. So let's start with why we should care about SQL. I took IEEE research on the most popular programming language in 2023, so last year, and there are three criteria: the most heavily used languages, the languages that are most often presented in job offers, and also languages that are the most trending. So the usage of those languages is growing. So in terms of the ranking itself, you can see that SQL is number 7, which is a strong position, especially taking into consideration that only Python and SQL are two languages for working with data right now. Maybe Java also participates in that, but let's be honest, Python and SQL are the most heavily used languages. Lesson from this picture is that you should consider Python as your next language to learn. And the other reason for that is because while SQL is number 1 language among job offers, so this language appears in most of job offers on the market, you will also see that SQL is typically not the only language in the specific job offer. It appears typically with several different languages, or at least one. And Python, guess what? For data processing and data engineering, a combination of SQL and Python is a typical requirement. So make sure you have SQL plus something else, at least basics of Python if you want to really work with data engineering. That is something that I would advise, and T-SQL Rex as well. So with that, keep in mind also that SQL is still trending. So we see different use cases for SQL language. Yet Python is again number 1, And the reason for Python to be #1 in trending language is, of course, the domination of AI. Right now, we have the boom of generative AI, and still Python is the language which is most often used for operating with LLMs, working with models, and doing some generative AI applications, right? So with that, let's move to Microsoft Fabric, because that is the purpose of the session. I don't want to speak about Microsoft Fabric itself for a long time, because I believe we already got some tips from Kim on the keynote. So just to wrap it up, Fabric is a software as a service platform for end-to-end analytics, where you can bring the data to one central data lake, which is called OneLake. And then work on this data effectively using different experiences from data engineering, real-time analytics, data science, through BI, classic BI, using Power BI, or well-known tool, #1 tool on the market. So the main thing is also that this whole platform has been built on top of Power BI architecture. So look and feel is very much like in Power BI. The 7th experience is called Data Activator, and it's about going from insights to actions. So you can actually start and trigger some actions based on data from your analytics. One request that I have for the audience, if you can mute yourself, that would be helpful. There will be some time for Q&A at the end of my session. Thanks. Thanks in advance. Okay. So when we know what Fabric is, let's think about where SQL can be used in Fabric, and what else can be used apart from SQL to work effectively with data. So first of all, OneLake is this center where the data is stored in Fabric. It's one central data lake that Fabric brings as a out of the box. When you set up a tenant, you have OneLake in place. And the good thing is that all data items can store data. They do not store it by default. Not all at least, but they can store data in OneLake. So you could have access through a single storage layer to all the data in your Fabric solutions. Two most important data items for you as a SQL developer or data engineer will be warehouses and lakehouses. A warehouse is a classic relational database where you work with transact SQL, just like in SQL Server, while lakehouse is a file-based solution where you cover files with SQL layer, let's say it. So you create tables on top of files that are stored in data lake. The good thing is that, so let's start with a lakehouse maybe, because lakehouse will be probably a typical start for you in Fabric. So you can work with lakehouse and SQL in two ways. First, you can access data sitting in lakehouse tables using SQL Analytics endpoint, which is created by default whenever you create a lakehouse. So it's a kind of SQL endpoint where you can operate with read-only T-SQL transact SQL code. But also you can use Spark SQL. So when you start working with notebooks, probably Spark SQL will be your language of your choice if you are a SQL developer. But no, please note that notebooks can also offer you also the possibility of working with other languages like Python, for example. So you will be switching between different languages in notebooks, for example, between Python and SQL. The good thing is that both warehouse and lakehouse can be accessed using your favorite tools for SQL developers. So SQL Server Management Studio, Azure Data Studio, Visual Studio Code. All of those can be used to access effectively SQL Analytics endpoints, so lakehouse, and warehouse using Transact SQL. The connection strings look very much like for Azure SQL databases or SQL servers. So you just provide a server name, you use your Entra ID identity, and then you log into a specific endpoint and connect to your databases. Also, when you store warehouses and lakehouses in the same workspace in Fabric, you will be able to run cross-database queries using Transact SQL. Again, this can be useful when you want to effectively join data that sits in different data items, warehouse and lakehouse, for example. There is also a way to connect data sitting in different workspaces. You can use shortcuts, which is a pointer pointing to specific table in specific data item. So, for example, if I have a warehouse and a lakehouse and I both sit in the different workspaces, I can create a shortcut in a lakehouse pointing to tables in a warehouse, and then effectively query the data from both data items without data movement. This is critical. You don't move data. You don't create silos, copies of data. With shortcuts, you can access data sitting in any point of OneLake. There are two other data items which you may find also available for querying. One is KQL database, and it's Custo database. If you are familiar with Azure Data Explorer, this is exactly this database. So this database will be used for real-time analytics, observational analytics, most of all for log analytics and telemetry analytics. So whenever you have appendable data with some semi-structured JSON data, that will be a great solution for you. And the natural way to access a KQL database is using KQL language, but also you can use T-SQL queries to access KQL data. The second data item is a semantic model, previously called dataset. Surprisingly, you can write semantic model to OneLake as delta tables, and then you can create shortcuts to this semantic model in a lakehouse to query a semantic model using Spark SQL, not T-SQL. Just keep in mind that in preview, semantic models stored in OneLake can be only accessed using Spark SQL. Also, you have the possibility to connect to semantic model using Spark connector and semantic link. So you will see that in a moment in my demo, and this can be useful to access and validate your semantic models, or even refresh data models if you want to using semantic links. One thing to note: warehouses and lakehouses store data in OneLake by default. For KQL database and semantic models, you need to take some steps to put the data in OneLake. Another thing to note is that Fabric standardized tables on the Delta Lake format. So every table that you will see in Fabric that is created by default somehow by Fabric tends to be Delta table. So warehouse stores data in Delta tables. Lakehouses in tables section will create Delta tables by default. And KQL databases and semantic models exported to OneLake will also keep data in Delta Lake. That is important. This is the standardization on open source format, which can be easily consumed by different platforms, for example, Azure Databricks. That's not it, because you also can create shortcuts to external storages like Data Lake Storage Generation 2, Dataverse behind Power Platform and CRM, Dynamics 365, Amazon S3 buckets, and in the future you will be also able to create shortcuts to Google Cloud Storage. Right now it's in private preview, I guess. The purpose of those shortcuts is to make data from those external storages accessible for, again, maybe SQL queries through lakehouses, so you can create shortcuts to those storages, especially when you keep Delta tables in those storages. That may be an immediate way to present tables from those storages to Fabric users. And last but not least, there is a private preview of mirroring feature, which is about bringing data from external databases like Azure SQL databases, Snowflake, and Cosmos DB to Fabric warehouses. So you will have tables coming from those external databases replicated to Fabric almost real time to be available for SQL access. So with that, let's wrap it up. Beyond SQL, going beyond Transact SQL, if you come from SQL Server world, the first thing to consider in terms of learning for you are Spark SQL. This is a natural extension to other SQL dialect. Delta Lake format. You need to learn the capabilities of this format and why it is so important that Fabric standardize on Delta Lake. Shortcuts, because this will be your friend in terms of not copying data across your Fabric tenant. And direct lake, which I haven't mentioned yet, but it's an important important factor when you consider your data engineering stuff like warehouses and lakehouses to work effectively with semantic models for Power BI. This is a new mode for accessing data in warehouses and lakehouses from Power BI. I don't want to cover that because this is a big topic, but just make sure you become familiar with direct lake. And also there are some ways to bring data to Fabric like pipelines and data flows. So make sure you are capable to bring data to Fabric environment. In terms of architecture, I would suggest to go for medallion architecture because, as you can see, Lakehouse is in the center of the universe in Fabric. So make sure medallion architecture is something that you are familiar with. Two things that you may consider optionally depending on your use cases and scenarios. KQL for working with KQL databases and semantic link if you want to work with Power BI. With that, let me switch to demo. I don't have much time, but let's try to cover as much as I can. So I'm in the Fabric workspace. So working with Fabric reminds very much Power BI. You have workspaces, so treat it as a folder. Actually, workspace is a folder where you store your data items and items that are for working with data, like notebooks, for example. And in my case, I will be using ready to use items. I will not be creating any item from the scratch, but just in case, you can switch between different experiences in Fabric to quickly get your favorite data items accessible for you. So, for example, if I'm a data engineer and I want to work with Lakehouse and notebooks, then I will just switch to this experience, and this will bring me to quick creation of Lakehouse, notebook, etc. And one thing. The difference between this environment and environments that you might be familiar with from Azure is that in Azure you provision something, you provision compute power, etc. Here, if once you have capacities established for supporting Fabric, so either P1, P2, P3 Power BI capacity or Fabric capacities created in Azure or bought from M365, you can go and start creating items for Fabric like lakehouses, but the only thing that it takes is just click on the button and give it a name, and that's it. You are not creating any clusters or anything else. Well, that's a half of true, because for Fabric workspaces you can set up your Spark environments, but the first impression is you just create items by providing a name. So I have already created Lakehouse and Warehouse for the purpose of this demo. Also, I have KQL database and semantic model. So all 4 data items that store data, possibly in one lake. So let's start with a brief introduction to those major data items that SQL developers work with. Let's start with the Lakehouse. Hopefully this will load. Okay, so this is the Lakehouse. Notice that there are 2 sections of the Lakehouse. The bottom one is called files, and here you land raw data like just files, pretty much anything you want to analyze. So those can be CSV files, Excel files, Parquet files, whatever you want to load. It can be also binary data like images. Whatever you want to analyze, you will put it here in subfolders. Creating subfolders is just as simple as clicking on the files or any folder and creating new subfolder. Also, there are different ways to load data to the files section. You have the Get Data button that allows you to upload files from your own computer or from OneDrive. You can load data using two different mechanisms of loading data available in Fabric: pipelines, which are more about orchestration or easy copy of data, and data flows generation 2, which are about data transformations with Power Query that you probably know from Power BI. And also you can use other mechanisms, but I will not cover those I will not cover getting data in this presentation. Just keep in mind that the easiest way to load data to your lakehouse is just simply upload files. So that's what I did in my case. I uploaded some data and I created some tables in my lakehouse. So tables is the second section, and please note all the tables that I have here are stored in delta format. This can be actually recognized by those little triangles in the icons. Whenever you see a triangle, it means that it's a delta format. And again, keep standardizing on delta lake format, because that will bring you the most benefit in Fabric. Now, you see that I can preview the data that sits in specific tables. Also, the same applies to several file formats. But also, please note that in the top corner, in the top right corner, I have this little switch with Lakehouse button to switch between Lakehouse view, Lakehouse Explorer view, and SQL Analytics endpoint. And when I switch to SQL Analytics endpoint, I can start writing my SQL queries. This is the place when I start writing my queries. So let's just go and write some T-SQL, right? So you can see that I can select data from some metadata that looks pretty much like in SQL Server, for example. I can select a list of my tables in my lakehouse. Again, those are delta tables, which are stored in tables, the managed section of the lakehouse. The ANSI compliant system views from information schema are also there, so you can rely on them as well and use those tables, those system tables as well. Now the good thing is that the metadata layer is similar to SQL Server. The bad thing is it's not the same, so you have to explore, for example, which dynamic management views are not available. There are just a few of them available for both lakehouses and warehouses in Fabric, but I leave it to you. I will not talk about which DMVs are covered in Fabric. So let's just maybe execute some more queries. So you can create views on top of lakehouses. Again, T-SQL endpoint or SQL Analytics endpoint for lakehouse is a read-only endpoint, but you can create programmatic objects like views, functions, or procedures. So, for example, here I am creating a view on top of my lakehouse, and it's done successfully. So you can present people with views. It's not the best approach if you want to use Direct Lake, because Direct Lake will work only on tables, but this is another topic to cover. So again, T-SQL read-only access to lakehouse is through SQL endpoint. The second artifact the second data item that I want to cover is warehouse. This looks very familiar, very much like SQL endpoint view. So it presents a list of tables, views, functions, and whatever you have in your warehouse, the data preview. But also, still, you can switch to query tab and start writing your SQL queries. And with warehouses, you typically work just like in SQL. So, for example, you can create tables. Again, in warehouses, you can write data using Transact SQL. So I can create my table. So drop and create actually. Then I will use copy into to bring the data from my lakehouse. Surprisingly, now this address can be easily taken from Lakehouse Explorer. Just go to specific file or folder and click on the properties and select the correct path and copy that to your copy into code. And that will bring the data to your newly created table. Just it's very similar to how you used to work with Synapse in terms of bringing data to, for example, dedicated SQL pools. So if you've ever worked with dedicated SQL pools in Synapse, this is the same, right? So I have my data in my payment type table, 6 rows, and I can easily insert the 7th row if it's missing. And of course, there are 7 rows right now in my table. Now, also keep in mind, I can run cross-database queries if I have 2 data items sitting in the same workspace. So in this case, I am querying a table that sits in demo lakehouse that I shown you just a second ago. And then I can build my analytics queries on top of 2 different data items. So imagine there can be data owner or people working on specific data products in a lakehouse, and there can be another team working with warehouse, and I can effectively join this data without duplicating, moving between different data items, which is a great advantage of Fabric when you compare it, for example, to Synapse. And also you can use statements that are very similar to Synapse again. For example, create table as select works perfectly. So for example, I can, in my warehouse, I can take the data that sits in the lakehouse, transform it in some way, and put it in a new table, new fact table in my warehouse. So whenever you will be playing with medallion architecture, creating your bronze, silver, and gold layer, that could be a method of creating the final gold layer if you decide to use warehouse for this layer. Just create a table based on what you have previously created in your lakehouses. And then the same rules apply to warehouse when it comes to access control. So you have the statements like grant, revoke, deny to control who has access to which tables. You can create roles and play with roles if you want to group people having the same access level. You have row level security, column level security on top of warehouses if you need to control access specifically. Let's go back. I have actually a notebook that should be my control plane. So let me now switch to the notebook, because notebooks are the way you will work with, you will use to work with lakehouses. So working with notebooks, the first thing to note is notebook is not just about code. It also contains Markdown, which is about text and images and whatever you want to describe what's going on in your code. So you can document your code effectively. So in this notebook, you will find, for example, a link to the data that I used for the demo that I'm presenting. And also you can see how to effectively drag and drop your files or tables to create some code without even knowing PySpark or Spark SQL. Just bring your data from Lakehouse to the notebook, and this will create a new data frame, distributed table object that will store data from specific Parquet file, and then you can just operate on top of this data frame. So typical approach when you work with notebooks and you're a SQL developer is this. You use this magic drag and drop method to create data frames. Then you move from data frames to SQL objects like temporary views, for example. So you will store data from data frames from your files actually in SQL views. And then you can switch to SQL using this magical command %% to start writing SQL on top of your temporary views, and then maybe create persistent tables from the data that you transformed. So again, switching to SQL and working with Spark SQL in this case is super easy because you have this flexibility of switching between languages in a single notebook, and from data frame you can move to SQL objects. There is also a way to move from SQL objects or SQL code to the files, because you sometimes will need to write back data from your SQL transformations or queries to the files. So simply you use Spark SQL method to run SQL and get data into a data frame, and then you use write method for the data frame to save the data produced by SQL statement or whatever you have into the data lake, for example, into the file section of the data lake. So as easy as that. Now, of course, you can also query tables. So if I drag and drop a table, that will create this Spark SQL statement for me to query the data from specific table. So displaying and exploring tables, exploring files is super easy. Use display method or other methods that are available in Spark. But what I want you to show as well is that you can create tables using SQL. So whenever you want to create delta tables in your data lake, it can be created using, for example, create table as select, just like in warehouses. So again, moving between different layers of medallion architecture in lake houses is as easy as executing those create table as select. Now, note that delta is default format for writing tables into lake houses. Now, I mentioned delta lake. I just want to mention that delta lake is an important format, not just because it's an open source format, but because it offers you some capabilities that can be also used by SQL people. For example, you can use time travel. Here, I am inserting the 7th record in my existing table. Then I describe the history. Now, yes, table has a history of data, and I can see that my table has 2 versions, but then I can effectively query a specific version of data for my table, or I can use timestamps to move between different versions of my data. So imagine that something went wrong in your transformation and you have some unnecessary data in your table. You can get rid of it just by selecting a specific version of your table without those changes, those bad changes in your data. Also, please keep in mind that SQL is probably not the most powerful language available in notebooks, because Python has lots of methods and it can be also extended by libraries, which offer by far more more capabilities than SQL, or at least you can write some things quicker. For example, drop duplicates will immediately let you get rid of duplicates in your data frames or tables. For example, a fill method will allow you to fill your missing values with medians or whatever you want. So make sure you learn at least the basics of Python. I suggested some functions in my notebook that I will share with you as well. So that is the way to go. Now let's move to KQL queries. That just to blink with some KQL. I try to be as concise as possible. So here is the KQL database. The KQL database, as I mentioned, is great for append-only data, maybe with some JSON structures inside of this table. So in this case, I am storing stocks daily, which is just a history of stocks for several companies. And as I can see, the statement here in KQL, it is not very similar to SQL, but if you look at the logic of execution, it just takes a name of table and then it selects 100 of random rows from the table in this specific query. So the KQL statement goes every time in the order of execution. So you don't have it in SQL, right? So here I am filtering data by Microsoft ticker only and present just 2 selected columns. So if you translate it into SQL, it would be select date and close from specific table when ticker equals to Microsoft. So it's not that much different from SQL. Also, the good news is that for some not very complex SQL statements, you are able to translate and convert SQL statements to KQL. You just write explain method, explain command, and then write your SQL, and in return you will get KQL code. Now KQL may be a bit more powerful in specific scenarios, especially for working with text. or some data that can be that can cover some processes. In this example, let me not go into details of this code, but this example presents a bit of process mining, because the question that I ask in this query is, show me in Microsoft stock what was the period when the stock price was growing day by day. What was the longest period? So imagine writing this in SQL. Well, that would be a piece of code. Here, there is a construction using the scan function that creates a kind of a process. So step one, step two, and then just detect whether conditions are met for the next step to add records to specific process, and then it returns aggregated data. So it is quicker method than in SQL to present this analytics. So just keep in mind that. Now, if you want to work with shortcuts to if you want to work with shortcuts to KQL database and semantic model, you need to take several steps. For KQL database, you need to go to KQL database, make sure that KQL database itself is actually stored in OneLake, but for tables, you will have also OneLake availability, and you need to make this specific table active in terms of OneLake. That will save this specific table in Delta format to OneLake. And having this specific table from KQL database in Delta Lake, in Delta Lake in OneLake, will allow you to create shortcuts in the lakehouse. And the same applies to, well, not the same, but similar thing applies to semantic models. Here I am in the semantic models called sample model settings. And notice that for effectively creating shortcuts to semantic models, you need to select this option, OneLake integration. And this will also imply selecting option large semantic model storage format. After you enable those two, you will need to also execute the export method on top of your semantic model, and then you will have your model available in OneLake. And then I can go back to my just quickly go and show you some shortcut queries. So let me just maybe explain what I have in my lakehouse. Just go to lakehouse. So out of those tables that you can see here, everything that has this little sign in the icon in the left top corner is a shortcut. 1, 2, 3, 4, 5, 6 shortcuts out of maybe 10 tables. So more shortcuts than tables themselves. So dim payment type and fact strip are shortcuts to the warehouse. Financials and time are shortcuts to semantic model. Trip large is a shortcut to a lakehouse in another workspace. And stocks daily, as you saw, it is a table sitting in KQL database. I am accessing those tables without data movement. Now, to create this shortcut, just click on your tables. Make sure that the table that you want to create a shortcut to is in Delta format. And then you just click on Microsoft OneLake, and you have all the data items that you can access visible. Also, this is one of the not that many places where you can see where in which region the specific data items are stored. But hey, you can select those, and then let's just say semantic model is something that I'm interested in, and then you have a set of tables, and you just click on the tables that you want to create shortcuts to. That's it. So querying tables created from shortcuts is as easy as just accessing by names. You don't even specify that specific table is created from shortcut. It is available in the DBO schema as normally you would create a table. And note that I can create shortcuts to quite large data sets. Like for example, here I am requesting for table that has 1.5 billion rows. So imagine instead of copying this 1.5 billion rows, I just create a shortcut and that's it. Now, just to mention, you work with SQL tools, so you want to probably access your warehouses and lakehouses using Management Studio and tools like that. So just keep in mind, if you go to warehouse or SQL Analytics endpoint, copy SQL connection string is your friend, and then just go to Management Studio, and when you click on connect, paste the connection string, pick Microsoft Entra as your authentication method, and you should be good. This is the Management Studio connected to my workspace. I see Lakehouse and Warehouse. I can select data from, for example, metadata views to see my tables in Lakehouse. So that's it. Now I'm running out of time, so just a blink of the eye on one of the scripts that I have left, or one of the notebooks that I have left in my demos. Just maybe bring semantic model. No, semantic model is just ad hoc analytics on top of semantic model. So no, let me just bring additional stuff, semantic link. So two things about semantic links. So first of all, to have semantic link, which is useful for accessing metadata and data sitting in semantic models, to have this installed, you need to install semantic link in your session, right? Then the good method of easily having access using Spark SQL to your semantic models is just using native connector to Power BI. So you just set this specific Spark setting, and then you are good to go with querying Power BI data using this notation: PBI dot model name, table name. You should be good. But semantic link is not about querying data, but rather about accessing metadata most of the time. So you will be, for example, able to list your data sets, this time using Python. You will be able to draw your relationship diagrams. You will be able to even run DMX queries for accessing metadata and explaining the size of the model and which columns in specific tables consume the most of the size or have the biggest dictionaries. And also you will have ability to refresh your model. So there are a bunch of opportunities with semantic links. Now, I'm running out of time, getting back to my slides, and let's wrap it up. There is a documentation. Don't copy that slide. I will point you to the GitHub where you will find this slide deck. But just to let you know, Microsoft has it covered when it comes to learning stuff that I showed you today. Call to action: learn Fabric. You also heard from Kim. There is a new career hub where you can hear from experts, when you can learn from experts, and then just explore Fabric on your pace. Also use end-to-end scenario tutorials. I believe there are not four, but even more scenarios that will help you understand what is available in Fabric. And with that, I encourage you to go beyond SQL, Python, Delta Lake, and stuff like that should be in your tool set whenever you want to effectively work with Fabric. With that, this is the link to my GitHub repo.